So now, if I hit this run button, notice a few things. So here's asking, where do you want to put in the FEMM model folder, or what's the where do you want to put in the FEMM models? So again, every time it increments one of these values, it generates a file, an FEMM model file, and this just asks you where to actually put that file. Also, every time this increments, it generates a script file and asks you where to put that script file. That's where this is. And every time it increments here, it also runs an FEMM analysis, and it asks you where do you want to put that results. So here I'm just going to put it into this folder here. And by default, there's going to be under your documents, where am I at? Under my documents, there's a quick machine folder here. And so here's where it's going to put the FEMM models, here's where it's going to put the FEMM results, here's where it's going to put the scripts, and everything like that. So here's where it actually put one model. I guess I haven't ran this on this computer yet. But anyway, so it puts all these results file. Now, once the whole parameter sweep is over, it actually takes all of these results files and concatenates them into a single file. And that's where this combined results file folder name or file name is set for. Right? And then here's the path of your FEMM program, just so you can actually use it. And then it's going to ask you something. It's going to say what the number of FEMM processes that you want to run at one time. Now, note that the way this program is actually set up is that it builds all these different FEMM files, and I can actually open up any number of instances of this FEMM program and analyze any one of these files because they're completely independent of each other. So this question really deals with, well, how many instances of FEMM do you want running at one time? And it completely depends on your application. But if you look here, I'm going to need 256 simulations. So you actually get that number by saying you have 15 simulations here, and you have 15 simulations there. And, well, actually, I think you'd have 16 here and 16 there if you count the starting and ending values. So yes, so you have 16 and 16 simulations. So if you go look at your calculator, you take 16 times 16, you get 256 simulations. So we're actually going to get 256 simulations here. So the point of this question is how many of those do you want simulating at the same time? And you can have any number you want. The point is that if I put in 1, then I'm not going to completely bog down my computer. If I put in 50, I'm going to completely bog down my computer, and I'm not actually going to be able to use it once the program starts. And note that with 256 simulations, that's going to take a while. It could take anywhere from 30 minutes to 10 hours, depending upon the machine. So I'm just going to go ahead and write, let's say, 10 simulations. So I want to do 10 simulations at once. So once I hit this OK button, it's going to start simulating. Okay, so I kind of cheated in order to get this thing to finish. I changed the increment values from 2 to 10 on both of these. So instead of running 256 simulations, I'm only running 9. And again, I'm using a virtual machine, so I was kind of hardware restricted on how many simulations I can actually run. But the 9 simulations ran fairly quickly, even on this virtual machine. And what you end up with are a number of files. So the main file that you're going to get is this combined results file. And or I guess whatever you named it when you hit the run button. So in this file, you're going to see a number of things. So this tells you the height of the tooth foot, the width of the tooth, the angle of the rotor, the torque, and the flux density, just as we had picked out in this script. Those are the things we wanted to output. So the main thing here to note is that when you actually tell the file to output torque and this flux density, you're using these two variable names, right? And that's what will actually appear on these columns when this combined results file is actually created. Later on, we'll look at what is actually created with each results file. But now, as you can see, of how these actual parameter sweeps actually work. So the height of the tooth foot started out at 10, and then you swept the tooth width from 10 to 30. You did the same, then you incremented the height of the tooth to 20, and you swept the tooth width, right? Set it to 30, swept the tooth width. Okay. So that's the combined results that you get. Save. Now, along with other things that you get, let's look at the actual model files. So every time a model is created, it's stored in this FEMM models file. So if I actually wanted to look at the exact model for, say, the 9th run, right? So let's look here. Okay, so it's telling me it doesn't know what extension I need to use. So you have to go in here and find the FEMM program. So luckily I have it right here. Go into bin, right there. Hit OK. So here's what the 9th run actually looked like. So you can pick out any of these to look at. So here's the 4th one, and so on. And note that the only thing that's really changing is the tooth shape. So other things that you actually get to, here are the raw results files. So you can see here's what you're actually outputting, and once all the simulations are done, these files, each of these 9 files are combined into a single CSV file, the combined results file. So here are the script files that were actually created. You can see this. So this is what ran every time you opened up the FEMM to do every single analysis. So that's really it. That's how easy it is to do a parameter sweep using Quick Machine. So again, thank you for watching. Thank you for using Quick Machine, and I will see you in the next video.